So this is the last talk of the FLOSS UK 2017 conference in Manchester. I've been introducing stuff all day. I've just showed you how to make a Raspberry Pi talk Ethernet over USB. And now the final presentation is how you can use OpenSSH certificates to do distributed policy enforcement. Just a quick introduction for me. I'm Tim Fletcher, in case you didn't know. I am currently a code-operated DevOps monkey, stealing from Paul and Martin. However, on Monday, I start a new job at Late Rooms, doing senior DevOps engineering, whatever my title is there, for at least 6 months. If you want to stalk me on GitHub or Twitter or email, there's a striking similarity there. You can probably find some other accounts with a similar setup. Before I start, who here knows what an SSH certificate is, who I haven't told?
I already knew anyway, so I'm going to keep my hand.
That's not too bad. It's not completely unknown. Because very few, I do a lot with SSH, as people know, and I've never heard of them until a few months ago, so I thought it was really quite interesting. So what problems are we trying to solve with this? I do consultancy work for people who have two sorts of systems. They've got embedded hardware, and they've got cloud systems. So with embedded hardware, they're small systems. We don't want to be running extra management tools. We don't want to be running Puppet on them. We don't want complicated LDAP binaries on our embedded systems. We want simple open source software, standard as possible, which is built for that system. One of my customers does building management systems. They are embedded on your building management network. It's restricted, it can't see the internet, it may not be able to see authentication servers, it may not work reliably. This is a building management network which is probably put in by the local building engineers who are firm believers in drills. It's IoT. We don't do updates. I didn't say that. We do updates sometimes, but we really don't like changing core components without a good reason. And that means that when you change the SSH key, you have to be very careful that it's been tested and it's not locked anybody out and it's actually gone through properly, and we bake it into the image. If you bake your keys into the image, it's really hard to change them. Similar problems in cloud systems. Minimal system software. Alpine Linux doesn't run very much. Debian, whatever the like Debian is, doesn't run very much. The CentOS Minimal has very little software installed. But everything seems to have SSH, assuming you want to do some management of it. Not all Docker containers have SSH. Again, people don't want to be running Puppet inside their instances if they can avoid it. They don't want to be running great big chunks of authentication and management code inside their minimal cloud instances. That's familiar. That sounds like that sounds like the idea we were talking about before with an embedded ARM system. And we don't want to change our golden images, or we want to build them and then keep reusing them. We don't want to wait for our management servers to install the right key so we can log in. We want it to work straight away out of the box. And that doesn't mean that we need to copy the SSH private key for our repo up onto a server which is exposed to the world without any keys, because, well, Ansible wants to talk to the SSH servers. So spinning up and tearing down cloud instances needs to be quick and efficient. How many people have seen that? Has anybody ever read the key and compared it with their original key? That's more than I expected.
Not every character, I have to admit.
So that's my server. That's in Bytemark, if you know IP addresses. I deliberately triggered that. So you can also use SSH certificate authorities to avoid that. SSH is, if fully used properly, SSH is end-to-end secured. It is end-to-end secured against man-in-the-middle and against wire-level monitoring and/or interception, or even really clever three-letter agencies who can manipulate your bytes on the wire live real time, they still can't get around that if you actually have all the crypto in place. I'm assuming people know SSH keys at this state, what SSH keys are, so I'm going to run through it pretty quickly. Secure shell, you can log in with key pairs, public-private, standard public-private cryptography. You publicize a public key, you drop it into your server's authorized keys file. You keep the private half, which I'm sure is kept stored securely on your laptop with encrypted hard disks and with a strong password. It's one of my talks. It wouldn't be complete without a YubiKey. My keys live on these. Actually, there's one on my Mac as well. My Mac has a password and has encrypted disks. Doesn't mean everybody does it. How many people have had to recover SSH keys from a left user's home directory? I spent some time doing that as well. You normally update SSH authorized keys to put in who can log into what. Sometimes done with central authentication. LDAP has reasonably good support for spitting out SSH keys when it's asked. Still requires a bootstrap process on the server of some description. If you've got even relatively small numbers of users using automation tools, it's hard to keep track of whose keys are where, who's allowed what privileges, who's allowed to log in from which IP addresses, and that increases complexity and increases mistakes. So you have SSH keys which can log in from the world, which gives you huge amounts of rights because that's easy. That's a public key off one of my YubiKeys. Can you tell that? If you drop that in your server's SSH authorized keys file, I could log into it. How do you know it's mine?
Only because you said so.
Yes. And how do you know that the one that I've sent to you hasn't been intercepted?
I asked you nicely for your fingerprint by a different channel.
Yes. But again, that's a level of work. So there could be a comment field there, but there isn't in this one. I've taken it out.
Not validated anyway.
Yes, the comment doesn't prove it.
No, it is not part of the key material. It is not signed. So when you log in with a SSH key to a server provides its public key. Bits in bold are what the civic authorities we're going to talk about will change. The client asks the user to trust it if it doesn't know it. Client asks the server to prove that it owns those login keys. That's the wrong word there. I've copied and pasted the wrong bit. The client asks the server to prove it owns those keys through standard cryptography. The client provides the public key for keys it knows about through SSH agent. Reverse process, the server asks the client to prove it owns them. The server looks at what restrictions you've set in authorized keys, because I'm sure you have all those locked down. Again, the two items in bold here, we're changing. This is what we're going to use. I've lifted this pretty much wholesale entirely wholesale from the OpenSSH release notes in version 5.4, released in 2010. So it's made it into most systems now. It's not X509, sort of similar-ish. You can't do authority chaining, so you can't have the standard SSL design of a master, subkeys, and potentially actual signing subkeys off that. Because that exposes quite a lot of, for the SSH people, they feel exposes too much of an attack surface. There's too much code, there's too much complexity. So this is, say, just a sort of introduction of how it came about and also how old it is. So we're on SSH 7.1, I think, at the moment. Maybe 7.2, I can't remember. And it's been in there for a number of years. It's been well tested. It works. What can we enforce? So we've talked about keys end up in your known host file, and authorized keys file in servers, that people say, I don't know whose that key that is, it's always been there. Or there's a key we put in from a master Ansible repo that allows us access, and you can do anything with that key. We can enforce where people are logging in from. We can enforce what they can do, both which commands they can run and whether they can forward ports, because forwarding a port in through SSH or forwarding your agent lets you circumvent huge chunks of firewall policy. You can build an SSH VPN very easily. You can build an SSH proxy very easily. It's trivial. It's easy to dodge people's firewall policies. But with a client certificate, we can say, you can't do that on that for that key or from this address. We can also enforce on the server side. So we can enforce how long the server certificate, how long the public key of the server is valid for. We can enforce what the server's host name is, what its IP address is. So this, as well as avoiding DNS attacks, lets us say, this is our server. So we expect it to be here, we've authorized it, and we agree that all these things match.
And presumably one stolen certificate for a host doesn't allow you to pretend to be any of the other hosts.
Correct. So you can bind a host to a key, to a certificate, to an IP address. This is an SSH certificate for one of my backup helpers, stolen from a talk some years ago. So, only that user can log in with this key. With this certificate, there's a private key behind the scenes. They can only come from these IP addresses. That's my Andrews and Arnold. These are all privates. I can't do anything else. I don't even get a terminal with this certificate. I can't forward any ports. I can't forward my agent. I can't run any commands. I know who can log in with the certificate, and only that person. I know when it's valid. So after that date, you can't log in with it. That's quite a long time in the future. This is a certificate I use behind the scenes for my backups. You could argue that there'd be a better way of regenerating it. Not everything is perfect. I could have assigned a serial number to this. That's again an arbitrary one. But this is who signed it. That one. So that's who signed it there. So you see, we've got a lot more information than just a key, than just the raw public key. And this is all backed up by cryptography. You can't change these because the cert doesn't work anymore. This is one which is signed by one of my consultancy customers, WEMS, based out in Stockport. So this is signed automatically. So it's signed by an estate management system, and you see how long it's valid for? So it's already dead, it's already expired. This one is a root certificate. This is IoT. We don't do anything without it being root. It's all fabulous. So we are allowed a shell, commit PTY, and we can come from these IP addresses. So again, privates, 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 the public IP address bound to the office, and that's it. So again, we know who's done it. If you know your Unix timestamps, that's a Unix timestamp. So we can revoke by serial number. We can revoke by the fact that time passes and the certificate stops being valid. The red's not wonderful. It also gives us much better logging. So I know it's hard to read. At the top there, that's a public key login to my server. It's me. So it's a user. That's who I've logged in as. That's a certificate. That's a key ID. Absolutely categorically know what that is. Everybody else can tell, I'm sure. This here is the same server logging in with this certificate. ID. Again, it's still a random number string, but at least we know who we logged in as, and it's signed by one of our trusted authorities, and we know where from. And so we've got IDs again, and serial numbers, and all of this tied together. So So we know we can follow a chain of authority for who's issued that certificate, when it was issued, how it was issued. This is pretty opaque. This is what you need. There we go. So anything more modern than that, any form of Ubuntu, that was now out of support, or about to go out of support. Rel6 and friends don't have it unless you do some package management stuff with Yum. Debian, even Debian's got it. Even the older Debian's got it. And if you want to run, if you want your Mac client to do all the certificate stuff, you need to have at least OSX Lion. If you're still only running OSX Lion, please buy a new piece of gear or upgrade it. And you need time synchronization. If you want to keep your, I'm standing outside the camera, sorry. If you want to keep your certificates short-lived, you need your time to be in sync. For IoT, for us, we do building management, the time's right, because otherwise, when the lights turn up 10 o'clock in the morning and it's not really 10 o'clock, the customer rings up and moans about it. But you do need time sync. The red still isn't great. So how do you enable this? Are people keeping up? Am I too quick? Okay. You add this to your SSH config. You add this. Trusted authorized principals is who can log in with a certificate. If it's not there, anybody can log in, and it's enforced by the certificate. Those are keys you trust. The keys are in a really useful format. Do I actually show the format? No. The keys I have failed to show you the format of, but it's basically a cert authority, @cert authority, and then an SSH key ID. It's the same format. Authorized principals, just a list of a text list of who can log in as. So this is how you make your SSH client trust that's how you make your SSH client know to look at the authority, the server's certificates. You can.
So the first one presumably goes in your authorized keys file to
yes.
say that that's CA and allowed to vouch for somebody.
No, that's a copy and paste error. This is a transcription error.
Right.
That's your server trust. So you can also restrict who is allowed to log, who when you connect to, you will trust to be certified. So you can tie your certificate to your domain name or to your Devel domain name. And then you combine this with SSH Bastion hosts where you control the environment. So you have the user's environment under control, and you know that I know what I've transcript now. So you control your environment with a Bastion host, you generate the keys, you control what hosts are allowed to show an authority certificate. This here should be in the server config there, so that's there. I've copied and pasted the wrong bit of slides around. So is anybody interested in this? Cool. This is how you sign a certificate. It's all you've done with SSH keygen. Public key of the server, key ID, so what you want the server to log, the principal or username, how long it's valid for. By default, SSH keygen adds 5 minutes in the past as well for you. You can stop it doing that if you're absolutely confident of your time sync. And the actual public key. So that gives that person, without having to touch your server at all, access. This is an example of an SSH client connecting. I helpfully highlighted the useful bits in red. Where's the colour in this thing? Sorry?
Left a bit.
The A next to the bulb.
So it is. I love computers. So now we can read this again. So my server provides its host certificate. Remember we saw before when we connected to that, we got prompted to trust the key. Don't get that anymore. It tells me it found a CA key. It tells me it matches. And it just logs in. No user interaction. If anybody here uses Ansible to log into new systems on a regular basis, it's quite irritating. I've written a whole playbook which sorts out my SSH known hosts. So this one removes that whole level of complication. And it also means that when your server is retired, somebody else can't steal its keys and recycle them. I've passed one demo, so let's see if I can do two. So we're going to show, generate a fresh brand new SSH key. Don't talk to my server, sign it, log in with it, show that it works. I'm signing it with a YubiKey as well because I'm me. I'm unsetting my SSH agent, otherwise my agent will intercept things and start logging me in automatically with other keys. So
You'll need to do SSH agent bash presumably because it's complaining about.
I know I don't want an agent.
I don't want that. You want
Yes, yes. So my agent can't talk to it. So no keys. So if we do, it's not working. Fresh brand new key. It's not working. There we go. So I can log in, well, that's who signed it. I can log in for the next 5 minutes. I don't get a PTY, but I can log in. Can't forward any ports. I can't do anything. Let's sign this again. So I'm now going to re-sign my key with one command allowed. No interaction. Can anybody see any scripting possibilities? So if I want to pass commands to SSH, that's the way you pass commands to SSH. So I want to try and do something else with my key. No dice. You only get one option. I passed. What can you do with this? Feel free to volunteer other ideas. You can automate your clients getting keys. We have, for our management hosts, automatically keys are generated and signed for an hour when people log in and open a shell. So they're signed, only come from that management host. They only can do certain things, and they can only go over our network. It's a very simple shell script, and it dumps out a signed certificate with no user interaction. but there's a key on the system which is unique to that system. Never need to touch the never need to touch the embedded systems, just works. You can do what a lot of the cloud scale providers do. They have bastion hosts that you have strong two-factor authentication to. You log into them. They have restricted network access. They have heavily monitored systems. They manage all of the keys. The keys never leave those hosts. They are generated automatically. They can log in. You can control with the certificates what they can do with them. You can also restrict your development team to only logging into the development servers. You can restrict your management teams to only logging into the servers they're responsible for. Again, all enforced by the remote systems. No, the systems don't need to be checking with online authority. So your LDAP server behind a firewall which has got broken ARP tables doesn't need to work. This is enforced at the client end. No DNS required, nothing, just SSH. Think about it the other way around. You could have, at the end of your build processes, the new cloud server submit proof that it has installed all its packages, installed all its updates. This is its public server key. You sign it with your trusted authority, and then you can log into it from your trusted clients. And if it hasn't passed all its tests, it doesn't get its certificate signed. You can't log into it. Because again, you're controlling the environment, so you can say you can't bypass the trusted auth. You only get bounced. You don't have to manage SSH keys anymore. The key is unique and private to you. It's completely irrelevant about its contents. It's only ever used in conjunction with the certificate that you've issued. Your servers, you don't need to log in and change the keys. You don't need to rotate the keys. You don't need to manage any of the process around that. You just sign a certificate. So these are the people who use it. Some names you may recognize there, one you probably don't. So Netflix have released one which runs a management server as a Lambda function. So you request access to go through their process, and then you get a certificate back. That's all in Python. Facebook have talked about it. I can't remember if they've released any code. And Uber, 10 days or so ago. I make no judgment about the policies of these companies. I'm merely observing they use them. They have released some software which is also about continuous verification of SSH keys and around certificates. My customer has released a PHP-based version of this, which we use internally. It's relatively simple. There's an example client and an example server. It's not at these sort of scales. It doesn't have the huge requirements for complexity or for how many systems you're managing. We're managing hundreds of systems rather than tens of thousands, as some people are. That is an extremely detailed walkthrough of all of the processes. Any questions?
So, this is great, and I'm actually a big fan of this. And several years ago, I wanted to use it with stuff on CentOS 6. So, but the thing that strikes me is that you have a new problem in that you have to keep your signing keys for your SSHCA very safe, or you have to rotate them more often,
yes,
or something. And because there's no specific delegated ones, because it's not X509, then if you lose them, it's the root key for the CA.
Yes.
So, how do you sleep at night knowing that there is a key out there somewhere? In this case on a key ring, but that allows you to sign certificates for this?
You're only dealing with one set of cryptography. You're only one set of key material. So managing one single. That's my example. Managing one single piece of key material is much more straightforward than managing potentially tens or hundreds of pieces of key material.
Sure.
And
it's a very juicy target now.
It is a higher value target. It also means that the people who manage the keys are focused on, that is one of their key tasks in more than one phrase. It is no longer you have to trust your users to keep their keys on their laptops with passwords. I know one of the universities represented here disables key-based authentication because they don't trust their users to keep them secure. Because once you have a key, you then can log in from anywhere. And keys are much more trusted. So there isn't a right answer. It moves the problem about. You need to work around rotating your keys. The actual embedded systems we push out, we have 3 keys in them. The master key, which is on all systems, a key which is unique to the client, unique to the customer who's bought the system, a backup paper key stored in a safe, and the next round of key iteration. So we have a way of rotating the keys. How we rotate and when we rotate is an unanswered question yet, but we have relatively secure storage of key material. It also means, as you say, my key lives there. I don't have to trust my users to do that. I don't have to help my users do that. I don't have to force my users to do that with fire and brimstone. I do that for them. I sign their certificates for a few minutes to give them the access that they require. And there's an audit trail. So there isn't a right answer. This gives you an idea how simple it is, about how you read bash. Effectively, I submit a key to an API endpoint and I get a certificate back. I write that certificate out. It's obviously on GitHub, it's fully shareable. If you like it, feel free to contribute. Feel free to tell me my bash is dreadful, most people do. It's better than my Python. Any other questions?
I noticed with your no PTY, no anything else demo,
Yes.
that when you type df, it actually returned df.
Correct.
Why? When you say you have no PTY or anything.
Having a no PTY doesn't stop you doing things, doesn't stop you running a command.
It's not the same as no shell.
Right.
I can't enforce.
You do have a shell.
Yes.
It's not a pseudo-tenant.
Yeah. Which is also why you
Can't type Control C.
you're quite limited in what you can do, and Vim will get really grumpy. But you can you can, if you're getting towards that level, you need to start then either considering whether or not you want to allow your users to log in at all, as in authenticated in a different way, or then you start to control their shell variables.
Yeah. So you mentioned about revoking keys.
Yes.
Based on serial number.
Yep. There's this concept of certificate revocation in, where am I looking? You can include a certificate revocation list, which is just the serial numbers. It is not signed, interestingly enough, so you can drop your own revocation list in there without needing to know the private key. So that you need to be careful about. So this is why, if you look at my colleague's code, he logs key signing to a database. I don't know exactly where he logs it. This is in PHP. That's where he logs it to. Fab. My understanding is it does talks to a database. PHP is not my thing. So yes, you basically log it to a database. And then when you want to revoke a key, either you let time expire or you put the key's ID in a revocation list.
On the SSHD.
On the SSH server. So then you do need to touch your server, which is why you want to be pushing out short-lived certificates and just let time sort the problem out for you.
Presumably the time is the time at the beginning of the SSH session.
Correct.
And doesn't enforce a logout.
No. This is part of what Uber's software was about. They had a PAM module which would do a end-to-end SSH verification before sudo worked. So then, okay, they have still got a shell, but they have pretty limited rights. They have more restricted rights. because again, so you do the whole verification process.
SSH Bastion that you...
Oh, sorry, the SSH Bastion host, it's a concept rather than a piece of software. So you have a cloud instance or a server which people log into in order to log on onwards. Sorry?
An SSH gateway, basically.
Yes.
Some people call them jump hosts.
Yeah.
Yes.
They have multiple names. You can ask, SSH has good proxy command support, but the key idea is that you're pushing peoples through a strongly controlled host for the key management process. So people would do potentially two-factor authentication, possibly they log in with the username password, one-time passwords for those hosts, and then the keys go onwards into automation tooling.
How does this fit in with the authentication methods plural configuration setting for SSHD, which allows you to specify that you must satisfy, say, at least two, or any one of a pair of them? Can you say, oh, well, I want a certificate for the user, plus there's a key that's baked into their TPM on their laptop, and I want a certificate to prove the host as well, like Windows-style key chaining when you log into the VPN or something?
I don't know. I've never tried it. Feel free to feedback.
Cool.
Can you combine it with a multi-factor authentication?
Possibly. I think you can, but I'm not quite sure how you'd go about configuring it. It's effectively, can you combine a key with an with a 2FA, which you can because you get prompted for the 2FA password by the second level of PAM modules. So you can still leverage PAM on the system.
But that's an option, isn't it?
Yes.
You actually take note of PAM at all.
Yep.
But the authentication methods plural thing, I was sorry to butt in. I was going to say, Duo Security, for example, have got a plugin for SSH that doesn't rely on PAM, so you can specify that one of your authentication methods must be Duo Security in addition to a certificate or a password or whatever.
Yep. The advantage of this is because it's baked into SSH at a pretty low level. It does work with a great many things. And it makes the thing particularly makes one of my next thought processes is that you have a SSH key which is unique to every Ansible run. So before you start Ansible, you get a unique key for that run, signed to only access the relevant hosts. So potentially some sort of there's a two-way process saying what's in the playbook, what should be in the playbook, and then you sign that for access to only those hosts. So again, you're starting to use centralized policy decisions to enforce on all your systems without them needing to talk to your central policy servers. Anything else?
I have one more, but I should let someone else speak first.
I think it's Thursday afternoon and people are asleep. Oh, gentleman behind you.
Do you think SSH is the future of the authentication on Linux, Unix-based systems?
It is so prevalent and so well supported. I don't see what, in the short term, I don't see what will take over from it. And there's lots of development time going into it because it is so widely used. In fact, one of our major competitors, the Windows operating system, has recently picked up SSH support. So you can SSH into your Windows server, you can run PowerShell, you can probably you can run Ansible against your Windows server through SSH. So as I said at the start, once you've got all the parts of SSH correct, it's very strong authentication. Both sides are authenticated, connections encrypted. If you twiddle with all the right SSH options, you've got very strong encryption in the tunnel. And Mac's gone to sleep. So yes, I think SSH will be around for a very long time.
So my other one was, you said you can also assign host keys to avoid the whole, this is a brand new host, would you want to trust it, random hash problem. But that means at the point you generate a certificate, you've somehow got to verify or trust that that the host key, the host public key that you're signing a certificate for is true, how do you personally solve the tofu problem for the host?
You've got, depending on what you're doing, if you're, so the two ones we're talking about right at the start, we can go about this two different ways. Let's find the right slide. So, for these things, embedded systems, we do the build process. We flash the firmware onto them. First boot is usually in a controlled environment. They can submit a key for signing. So we have confidence because it's one of our embedded systems on your build network that we can sign it. For a larger organization doing embedded systems, you may look at automating that process so that you have, yes, you have some level of cryptography in the system, and that could be lifted, you could get that signed, but you have to, and if you're having the firmware blown in China, then maybe somebody will lift that key, but you still have an audit trail. So this system booted at this time with this serial number, and we requested a key signing. So you've got a pretty strong idea what's happening. Not perfect. It's the same thing with cloud systems. You control the init process, you control the build process, you control the environment. Your servers will go through a build process, they will install their software, install their packages, and at the end of that, you will get some form of output. Potentially some form of predictable output. You can submit that to your authority process. You can design your authority process how you like in Python, Bash, Perl, Go, any other languages are available. And you decide, is this a system we trust? Does it pass our rules? And then you give it a certificate back. So it gives you pretty strong, again, you have an audit trail. This system, boot at this time, with this AMI, with this instance ID. So potentially, in Amazon, you could design, we've asked it for a new instance. Is this instance ID we expected? So there are many ways of doing it. I haven't looked at how things like people like Netflix, because Netflix is a huge AWS house. They may well call out to AWS's management stuff and say, are we expecting this host?
One suggestion I had read was that if you bake into your image a command on first boot after generating the host key to dump the public key to the console and then pull the console log from the API, then you already have your trust relationship with Amazon's API. And that
Yes.
was an example for AWS.
Yeah.
I'm curious to how you were doing it.
No, for the embedded systems, it's because we trust the environment. But it's moving away from your end users making a trust decision to your systems and processes making a trust decision. And your systems and processes can make much more complicated and nuanced decisions than your user at 4 o'clock in the morning trying to log into the system to reboot it. Anybody else? Excellent, thank you very much.